Good morning, students. Today we are going to discuss analytical chemistry, and in this the topic is related to ammonium hydroxide and sodium hydroxide. So first of all, we should be knowing about colored and colorless ions, right? So some colored ions are there. Mostly the metallic ions are mostly colored, but there are many metallic ions which are colorless also, like here it is given. However, this is just a summary of the chapter, so I will not be taking things in very deep because in online class I already explained this chapter. So there are some of the ions which are, you can say it is colorless, but many are being colored, right? So you have to learn these, otherwise you will not be able to answer so many things. Some colorless metallic ions is also there, and some colorless non-metallic ions is also there, right? This question is generally asked in the paper. Name a positive colorless cation, right? So you have to write NH4 positive, because in this case no metal is being used here, and it is you can say it is colorless, right? So some of the colorless non-metallic ions are also there, and some of the colored metallic anions are is also there, right? For example, permanganate anion, like that. So mainly in your syllabus it is the table related to sodium hydroxide, right? Action of sodium hydroxide. So this is the table which you have to learn. In see this in first calcium, it is going to form always this calcium salt. When react with sodium hydroxide NaOH, it will always give calcium hydroxide and sodium nitrate, which is sparingly soluble, as it is written here. Sparingly soluble means very less soluble, right? Means in 100 ml of water at room temperature, somewhere near to 298 Kelvin or 25 degrees Celsius, it is hardly soluble, less than 1 gram, right? So this is known as sparingly soluble. Then actually this table is related to ions, not to the particularly salt, right? Don't think that it is this reaction is applicable only with calcium nitrate salt. It can be applicable with the other salts also of calcium, right? Because we are talking about calcium 2 positive ion. Similarly, we are talking here about Fe2 positive ion, not FeSO4, right? Clear? And in this case we are talking about Fe3 positive ion, that is ferric salt, right? So this you have to remember, this thing, that we are talking in sense of ions, that is cations in case of metals, right? Similarly, when copper salt reacts with sodium hydroxide, pale blue precipitates are formed which are insoluble. These are insoluble, right? Similarly, zinc is also there, right? Zinc salt is also there, that is Zn2 positive ion is there. Zinc nitrate can also be taken here, right? You can take zinc carbonate also. In place of lead nitrate you can take lead carbonate also, PbCO3. It is your choice, right? But remember this thing, there are some of the exception, that in excess of NaOH this lead salt will dissolve. Means the precipitate of lead salt formed will dissolve in excess of NaOH. ठीक है? ये जो PbOH ट्वाइस बना है, ये एक्सेस, मतलब आप थोड़ी सी और ड्रॉप्स डाल दोगे टेस्ट ट्यूब में तो ये डिसॉल्व हो जाएगा, एंड यू विल बी गेटिंग सोडियम प्लम्बाइड विच इज कलरलेस, right? That's why it is written here chalky white soluble, right? Means precipitates will be soluble. Similarly, one more is there, right? Now we are taking this NH4 positive ion also here. Why we are taking? Because in case of colorless ions, NH4 positive is present over there, right? So we will be taking this also. Clear? Okay, so NH4 positive ion when react with NaOH, it gives NH3 gas, right? So this you have to remember. Clear? Right? And ammonia gas is evolved here. No precipitate is formed, so no such kind of a table is being made here, right? Remember this thing, it is a important part. Now we are moving towards the next topic, and that table is related to ammonium hydroxide table. This is ammonium hydroxide table. Now in ammonium hydroxide, this calcium salt, whereas in a previous table of NaOH table, this calcium salt reacting and giving white precipitate, but here it is not reacting. Why? Because sodium hydroxide is a weak base, right? So the concentration of OH negative ion from the ionization of NH4 positive NH4OH positive OH is low, so it cannot precipitate calcium hydroxide, right? A hydroxide of calcium. Similarly, see here also we are talking about ion. That's why in the book they are writing continuously 2 positive, Fe3 positive, Cu2 positive. And in this table you are seeing that here they are adding excess of NH4OH. Why they are adding excess of NH4OH? Because they are checking whether it is soluble or not. In previous table they are not adding in case of copper excess of NaOH. Here we have to add excess of NH4OH. Why we are adding? Because it is a weak base. There NaOH in the previous table is already a strong base, right? So here we have to add and check. Now students might ask, can we add excess of NH4OH here also? Yes, you can add, but it will remain insoluble, right? So these tables you have to learn. I am just giving you the basic things. Like here in case of CuOH twice, many students are thinking that here's book has taken calcium sulfate, can we take here book has taken copper sulfate, can we take copper nitrate also? No problem, it can be taken with the copper nitrate also. So remember this thing, the copper hydroxide formed in this case when you add excess of NH4OH. See, excess of NH4OH is being added, so you will get tetramine copper sulfate, which is soluble in excess of NH4OH, right? So similarly in case of zinc 2 positive salt also, zinc 2 positive salt, zinc nitrate or zinc sulfate, right? Similarly in case of lead nitrate, when you take lead nitrate, it always form insoluble. However, you can add excess of NH4OH in this case, but it will remain insoluble. So this is all about the table, and you have to learn these things: gelatinous, white, precipitate, and other things. Now we are moving towards this table. In this table they are showing that there are some metals, zinc, aluminium, and lead. These are the some metals. When they react with hot and concentrated alkalis, they will liberate hydrogen gas, right? So here in the first reaction, see here, sodium zincate is being formed, potassium zincate, and hydrogen gas is liberated. In next reaction also they are taking aluminium, reacting it with caustic alkalis like NaOH or KOH, right? It is being boiled with that. So here also hydrogen gas will be released. Similarly in case of lead also, sodium plumbite and hydrogen gas is released, right? So this table is important. Now we are moving towards a very important topic. As you know, this is just a video of full chapter, so it is only a main points: amphoteric oxides and hydroxide. Amphoteric oxide, ZnO is a oxide, ZnOH twice is a hydroxide, right? So oxides and hydroxides are those, means amphoteric are those which can react with acid also. And see here ZnO is reacting with acid, and here ZnO is reacting with the base, and base is what? NaOH, right? Clear? Soluble bases are also called as alkalis. So oxides and hydroxides are those which can react with both base also and acid also. So see, this oxide is reacting with acid also, base also, and this hydroxide reacting with acid also and base also. So amphoteric oxides and hydroxides are those. In your syllabus we are having 3 amphoteric oxides and hydroxide, that is of zinc, aluminium, and lead. Zinc means zinc oxide and hydroxide. Then aluminium oxide and aluminium hydroxide. For lead also, lead oxide and lead hydroxide. But their reaction is with only with alkalis. Their reaction is with only alkalis. So here they are reacting with alkalis, and they are some form colorless, like in case of zinc oxide, when they react with NaOH, they form a colorless soluble solution, right? Clear? And similarly in case of lead, if you will see, lead oxide is yellow in color, it will form colorless, right? Similarly in case of KOH also, it will form a colorless soluble solution, right? And zinc also you have seen, lead also you've seen. Now you see aluminum is in white color, alumina, right? It is also called as alumina. When they react with NaOH, it will form sodium meta-aluminate and H2O, right? So these are the few reactions which you have to learn, and it is very important. Thank you.